two lines that never meet are called parallel lines. And when we have parallel lines, we note them with little arrows around each line. That signifies that those two lines are parallel. When we have parallel lines and a line that goes across those parallel lines, the fancy name for that is a transversal, then there are different forms of angles that are formed. And there are different shapes that we can see in these angles. And the first shape that we can see is a Z shape. If we follow the pen here, there we go, we get a Z shape between the parallel lines. And when we have parallel lines, the little inside the crook of the Z, we have what are called alternate angles. And alternate angles are the same, they are equal to one another. It's like they're on the same transversal here, but they're on the alternate sides of that transversal. But actually, the angles on the opposite sides are also alternate. Again, they're also part of a Z shape too, slightly more elongated one, but they're on opposite sides, alternate sides, and alternate ends of that transversal. The second type of angles that we see around parallel lines are what we call corresponding angles. And corresponding angles we find in sort of F shapes. So I draw an F shape with my parallel lines being the branches of the F. Corresponding angles are in corresponding positions around the parallel line. So if I look at this one, it's just underneath the crook, and so a corresponding position will be underneath the crook of the other parallel line. They correspond to one another. If I were to take the F shape and actually draw it backwards, then this angle would correspond to this angle. They are in the corresponding positions. And so if we have parallel lines and a transversal line that crosses it, we can quickly find all the angles if we know one of them. One other property about when two straight lines cross is that we form four angles. And what you find is that the angles that are opposite one another are equal. We call those vertically opposite angles. So this angle in here is vertically opposite this angle in here. They are equal to one another. This angle here is vertically opposite this angle, and they are equal to one another as well. So if we have a pair of parallel lines and a transversal, what we can very quickly find out is that if we know one angle, we can work out every other angle. Because if we know this angle here, I know that this angle is vertically opposite. But I also know that if I can see my Z shape here, like so, that this angle is alternate with the original angle. And with the original angle, this corresponds to the original angle. Or indeed we could just say it's vertically opposite this one. So all those angles are exactly the same. And if we know that first angle, then this angle we can work out because angles on a straight line add up to 180. And if we know that green angle, then this green angle becomes exactly the same because it's vertically opposite. And these two angles correspond to the two angles above them. And so very quickly we can work out all four angles on each parallel line. And we find that all the obtuse angles are exactly the same and all the acute angles are exactly the same. In this example we have a pair of parallel lines, but we all have two transversals. So we have to take each transversal, each line separately. So let's look at X first. If this angle down here is 80 degrees, then I know by corresponding angles that this angle up here must be 80 degrees. Okay, there's my F shape there. towards F shape. And if that's 80 degrees, I know that x and 80 are on a straight line. They are supplementary. So x plus 80 must equal 180. X is 100 degrees. If another way of looking at the left hand side, if I know that this is 110 degrees, then the angle below it must be 70 degrees. And again, if you look between your parallel lines, there's a Z shape. So y is also equal to 70 degrees because it is alternate. But there are lots and lots of ways of working these out. I could have said that this angle up here is 70 degrees because it's supplementary, it's on a straight line. And if you look at your F shape, then y and 70 are corresponding. Corresponding angles are equal, so y is 70 degrees. So there are lots of ways of working these out, and as long as we remember those three significant properties of alternate angles, Z shapes between parallel lines, corresponding angles are F shapes between parallel lines, and vertically opposite angles happen whenever two straight lines cross. And each of these has the property that alternate angles are equal to one another, corresponding angles are equal to one another, and vertically opposite angles are equal to one another.